All right, everyone, welcome to the 6th screencast for Chapter 3 and the last one. And this is the screencast where we're going to finally have our supply and demand model completely built and ready to do some analysis moving forward in the next few chapters. All right, so we're going to put the supply and the demand all together on the same graph. And you'll be sick of this graph by the time, you may be sick of it already and you haven't seen it, but you'll definitely be sick of it by the first exam. But it is one of the models that we're going to use a whole lot in this class. All right, so we're going to bring supply and demand together. So how is the price of a good determined? All right, so the market forces of supply and demand work simultaneously to determine the price. So in a competitive market, and again, we're still working in that competitive market world. In a competitive market, no one person, no one consumer, no one firm determines the price. It emerges from the actions of the buyers and the actions of the sellers, all together trying to do what's best for themselves. All right. So the law of supply and demand work together. So the price of any good will adjust to bring the quantities supplied equal to the quantity demanded. All right. So this is a situation that we'll see graphically in just a second. Again, it's probably better for me to show you the computerized version than to try to draw it for you the first time. So this point where quantity supplied equals quantity demanded is what is known as the equilibrium point. It's an equilibrium. The metaphor is like an equilibrium in a physical system. So at equilibrium, unless something changes, the system is at a standstill. It's an equilibrium, all right? So graphically, this happens at the intersection of the supply and demand curves, all right? The equilibrium price is the price that causes quantity supplied to equal quantity demanded, all right? If the price is too high, this won't be true. If the price is too low, this won't be true. So the equilibrium price is the price that causes quantity supplied to equal quantity demanded. All right, so it's the price that sometimes we'll say clears the market. So all the buyers who want to buy at that price are buying. All the sellers who want to sell at that price are selling. All right, and so it's it clears the market. All right. So the equilibrium quantity is the numerical quantity that is equivalent to one another. So that's the quantity supplied equaling the quantity demanded at the equilibrium price. All right. So it's probably easier just to see this graphically, and we'll get to that in a second. But I need to give you a little bit more vocabulary, all right? So when you're not at that equilibrium point, when you're not at the equilibrium price or the equilibrium quantities, you can have a shortage or a surplus. So a shortage is when the quantity demanded is greater than the quantity supplied. So at some price, we have more people who want to buy it than who want to supply it, all right? And for some reason, the price is not changing, all right? So you end up with a shortage, all right? This occurs at any price below the equilibrium price. Price will then rise over time, if it's allowed to, toward the equilibrium price, and that will end up making us back in the world where quantity demanded equals quantity supplied. So why does price rise over time with the shortage? Well, consumers who value the product will start outbidding one another, right? Because there's not enough to go around. The quantity demanded is greater than the quantity supplied. So you could think of maybe there had been a natural disaster and it destroyed all of the power. And so there was a shortage of ice suddenly. The quantity demanded for ice is suddenly way higher than the quantity supplied, all right? Well, what would happen if legally it was allowed is that people would start outbidding one another for the little bits of ice that they could find, all right? Further, people might hear about the shortage of ice and the crazy prices that people were paying, and they might bring ice to that area, again, if they were allowed to do so. And so that would cause the shortage to eventually be gone, and quantity demanded would once again equal quantity supply, all right? So, all right. So the opposite situation is a surplus. So this is where the quantity supplied is greater than the quantity demanded. So this occurs at any price above the equilibrium price, all right? the price will fall over time toward equilibrium. Why does that happen? Why does the price fall with a surplus? Well, firms start undercutting one another, all right, in order to sell at lower and lower prices because they have too much on hand. You can't make any money off of product that you aren't selling, all right? So they will undercut one another, charge lower and lower prices until we get back to the case where quantity supplied equals quantity demanded, all right? So again, most of this is probably easier to think about graphically. So let's look at that. So here's a demand curve. Again, as the price goes up, the demand goes down. That's why there's a negative slope here to the demand curve. And here's the supply curve. Again, as the price goes up, the quantity supplied goes up. All right. So this is in price per pound, and this is in pounds per month, maybe of coffee. All right. So at $10, the equilibrium quantity is 500. So this is the case where quantity demanded equals quantity supplied, right? That's what this intersection means. The quantity demanded equals the quantity supplied, all right? What about at a price of $5? Well, at a price of $5, the quantity demanded here is, we'll call that QD prime, is 750, and the quantity supplied here, QS prime, is 250. All right, so now look what's happening. At a price below the equilibrium price, all right, the quantity that suppliers want to supply is less than the quantity that buyers want to buy. Buyers want to buy 750, and suppliers only want to sell 250. All right. So what will happen with this shortage is if it's allowed to change the price, slowly these buyers will start outbidding one another. All right. As they do that, some of the buyers will drop out. It won't be worth it to them to buy at the higher prices, so they will no longer demand the good. But there are suppliers willing to supply at these higher prices, so those suppliers will start to enter the market. These suppliers won't supply it at $5, all right? These suppliers. But as the price rises and goes to $6, say, these suppliers will enter the market. Both those forces push the quantity supply and demanded toward one another, and we end up at the equilibrium quantity and the equilibrium price of $10. What about at a price that's above the equilibrium price? Well, at this price, the quantity demanded is 250, and the quantity supplied is 750. So this is QD double prime and QS double prime. So now we have a demand that is much smaller than the supply. All right. So what will happen is that firms will start to undercut one another and start to charge lower prices, and these buyers who wouldn't have bought at $15 will now enter the market and start buying. These two forces together will push us back toward the equilibrium point, all right, at the equilibrium price of $10, okay? So here's a graph of shifts. So what happens, so now we have these things put together. Let's look at what happens in a supply and demand model, all right, when demand shifts to the right. And remember all the different things that shift demand. One of them was an increase in income for normal goods, all right? So let's say that happens, demand shifts to the right. What happens to the price? Well, the price increases and the quantity transacted between the two increases. All right, so this was the equilibrium quantity before, Q star. Now the equilibrium quantity is Q double star. And again, price, quantity supplied equaled quantity demanded here before, then demand increased, and now quantity supplied equals quantity demanded again at the new higher price. So here's P star, and this is P double star, the new higher equilibrium price, all right? What about with a shift in supply? So again, here's our original supply curve. Here's our original demand curve. So now supply increases, all right? So there's maybe an improvement in technology, and so suppliers can supply more at all prices. What does it do to the equilibrium when supply increases? Well, this was the equilibrium quantity before at this price of P star. Now we get a shift in supply, the price falls to P double star, and now we get a new equilibrium quantity transacted, which is Q double star. All right, so that's what happens in a supply and demand model when supply increases. All right, so what happens when demand falls? All right, well, maybe there was a change in taste and suddenly something fell out of fashion. All right, so demand shifts in. We were formerly at the equilibrium quantity here, the equilibrium price here, and this was the equilibrium point. Now demand falls, and so we end up at a new equilibrium price, P double star, and a new equilibrium quantity, Q double star. Right here is the new equilibrium point. So we get a lower price when demand falls, and we get a lower quantity transacted between suppliers and demanders. What about when supply falls? All right, well, here we are at the original demand, the original supply curve, and this is the equilibrium point. All right, this is the equilibrium quantity transacted. This was the original equilibrium price. Now supply falls. Maybe there's a natural disaster that destroys a lot of the capacity of the producers. Well, that will shift supply left or shift supply in. Price will have to rise. Price will go up to P double star, and we end up at this new equilibrium point, or a new equilibrium quantity of Q double star. All right, so that's what happens when supply shifts in. All right, so the last thing I want to leave you with is this clip from Willy Wonka and the Chocolate Factory, and I want you to think about what sort of market effect is happening here. Why is the price of candy bars increasing? All right, so I'll see you next time.